Brilliant. Thank you. I'll start again. So, bumblebee research is somewhat fundamentally flawed, which is an excellent thing to have to say, particularly to people up in another country who do bumblebee research. A cursory glance at all currently existing papers on bumblebee research done in the UK focuses on just one of those 25 species of bumblebee. That would be Bombus terrestris, the buff-tailed bumblebee. The other 24 species, outside laboratory analyses, stuff that's done in the field, with sort of haphazard studying, observing their behavior as they're flying around, the other 24 species are completely ignored, which means that we basically know very little about the actual true lives of our bumblebees. Now, that being said, Bumblebee Conservation Trust, of which we have a number of board members associated here at Lancaster University, which is lovely. Bumblebee Conservation Trust put out a great deal of really important, exciting information about bumblebees. One example here is this lovely diagram they present of the life cycle of the bumblebee. So what we have is right now, early spring, fingers crossed early spring stays with us for the next couple of weeks, you will have all seen a number of large queen bumblebees that have overwintered, nesting in little holes in the ground, flying around, looking at flowers, getting their food. Because what they're doing right now is they are storing up food for themselves at the one time of the year when they can get out and fly. And what these queens will do is they'll get together a ball of pollen and some nectar, and they'll find a nest site somewhere. I'd like to emphasize that. We do not know why or where they find these nest sites. That is a key issue that we have with bumblebee research. But they will find a nest site somewhere. They will create a little wax cup, and they'll place within this cup all that nectar and pollen they have found over the last couple of weeks. And they will use from that as their little food source to keep themselves going whilst they lay eggs, make their first batch of workers when we move into summer. Once the queen has made that little hole with her food store, she will never leave that hole for the rest of the season. She will stay there. All of her daughters, which are the worker bees, will go out and find food for her and bring them back to her. It's very much like honeybees in that way. And then at the end of summer, the queen bumblebee that's been living inside the hive will start to lay special eggs that make more queens. And these virgin queens will emerge. They will fly away from the nest. They will mate with male bees from other nests, and thereby produce fertile queens, which will then go back into hibernation and re-emerge next year. This is a beautiful cyclical lifestyle. It is, however, based entirely on observation and guesswork, and that sounds basically right, so that's probably what's happening, because we don't have decent experimental tools for studying bumblebees. We have some really beautiful, and I think this is a personal touch for me. I love to include the idea of a Heath Robinson designed bumblebee nest. These designs which are either knocked together box of wood, basically based on bird boxes. We've got upside down, not upturned plant pots with clay, and it's really lovely. And they are ineffective because they are, on average, you have about 5% successful recruitment. So those queen bees that fly out looking for somewhere to nest, looking for an ideal nesting site, you put one of these in your garden, you may get one once in your life, a bee nesting in there. The alternative you have, and this is one I've been working with, or looking at, trying to figure out what's exactly going on here, what the justification for this design, are the commercial bumblebee nest boxes. These are used primarily for horticultural and greenhouse growing stuff. So big indoors greenhouses for tomatoes, things like that. A lot of farmers will buy in boxes of bumblebees, which again are exclusively from that one bumblebee species, Bombus terrestris, and they'll bring them into their greenhouses, let them fly around and pollinate the crops for them. As you will see with both of these designs, there are some flaws. The Heath Robinson design, lovely, but you can only make a couple of them without running out of materials. The commercial design, they are made of cardboard, which means if you ever let them outside in Lancashire for more than a couple of days, they will melt. And that was the justification for a collaboration that myself and Jenny Roberts at the engineering department here at Lancaster undertook with, why don't we make bee nest boxes better? And that's why we introduced a BEEBOX. So we lack this way of making a lot of nest boxes. We like the ability to make thousands of them because we need thousands of them. We need to be able to use lots of nest boxes to properly study bee nesting behavior. We also need to do a way that's going to survive outside. And we also need to produce something that's going to enable us to collect data on it, so we can actually observe bumblebee behavior without disturbing it. So working together, Jenny being the engineer who understands how to make things, and me being the person who understands somewhat what bees actually require in order to survive, we made BEEBOX design version 1, which was made for vacuum forming. It has a little microcomputer made by Raspberry Pi, which I'm sure most of you will already have heard of. There's a small infrared camera inside and a small infrared light source. That is a very key important design feature of this nest box. In the wild, most bumblebees nest either in tree hollows or subterraneously, they nest underground. Very importantly about both of those sites is there's no natural light in those sites. So what we have to do for a proper nest box is to study bee behavior genuinely without being worried about impacting their behavior by looking at them, is have a way of observing them without using natural light, which is why we designed a nest box that has completely opaque design and an infrared light source because, again, bumblebees cannot see in the infrared. So we can watch them without them knowing we're watching them. And in doing so, we can observe their secret, hidden, forbidden lives. Now, today, we have the exceptional and brand new cutting edge redesign based on last year's experimentation. We have managed to get this working with a 3D printer now, which is fantastic. We're still in the testing phase because we have a number of environmental control and temperature control, humidity control issues that we're still trying to work out, even entrance issues we're trying to work out, but we are progressing, which is lovely to see. We have today with us version 2 of BEEBOX for you guys all to see for the first time ever. The new version contains a much larger internal chamber because my suspicion that the nest box of a bee needs to only be about this big was off, because that's how we do things in science. We guess and we test and we try, and we figure out what we did wrong, and we did something wrong, so we fixed it, which is wonderful. Now, I'm going to be very careful. Is there a mute button on here? Yes. Because last time I played this video, it was definitely loud. So fingers crossed. I'm going to do it on here as well. Those of you online, maybe mute your microphones for the next 30 seconds. This is the world first video recording of bumblebee behavior inside a nest box without them knowing we're watching them. There we go. And we have here bees feeding on cups of nectar. We have bees tending to eggs. We have a very young baby bee in here that's just moving around, just learning its environment for the first time ever. And these are, again, we've never been able to observe bees emerging from their cocoons inside the nest box before without them being disturbed by the introduction of natural light, without having to crack open the nest. This is genuinely a world-first amazing new opportunity to study bee behavior. And we had 2 talks in this session alone about the power of AI and video and for image analysis. What we can do with this video is, with future work involving the addition of barcodes on each of the individual bees, we can monitor their behavior and design machine learning algorithms to datafy their behavior based on different manipulations, based on the introduction of pesticides. We can look at the ability of parasites and predators coming into the hive. This video quality here is good enough in the short term for us to have that real clincher of, we want to see what happens when a cuckoo bumblebee, that's the same as the bird, a cuckoo bumblebee will come into this nest, usurp the queen, and start laying her own eggs inside this nest. That has never once been seen. And we will continue to be producing these videos until we get to that one special time in our lives when we finally get to see a cuckoo happening. Now, there is one other amazing cool thing. So I did mention earlier in the talk that at the end of the season, the bee nest the queen of that nest will start to produce young virgin queens, which will go off to be mated to form the nests of last year. If we are to use things like bee boxes in people's gardens, in agricultural land, in cities, to conserve and produce nesting sites for bumblebees, we're going to need to guarantee that those queens can emerge, that the nests can survive. And following a successful trial with version 1 last year, we did manage to do exactly that. So we had a nest which survived for over 3 months. And at the end of those 3 months, rather than the nest completely die off, which was one of our concerns and worries with version 1, that nest produced, as you can see here, one that I've caught, virgin queen bumblebees at the end of September. And yeah. Then the last final clincher. Those queen bees may fly off and they will never come back again. And the low recruitment rate of existing nest boxes is a real problem, which is why I'm very pleased to tell you today that as of Friday last week, I have an interested queen who's come back, may not be from the same nest as last year, but she has come back. See, she's real. It's very hard to catch a good video of her because I'm just plugging in a little camera tube, but we have queens inspecting nest boxes that were abandoned last year with the idea of, oh, maybe I'll set up a new nest in here. So please do watch the space to see whether this queen does actually make a new home this year. The other really neat thing about this, and the thing that's so great about science, because I get to tell you all about this stuff, is that people love bees. People can sometimes be a bit intimidated by bees. And having the ability to see this biodiversity, see the natural world, gives people a real sense of connection to it. And that's one of the great strengths of BEEBOX. We have the ability to run a video live stream from the video camera placed inside the nest box to YouTube. And people can tune into YouTube and watch this live stream going, much in the same way as people tune into the chick live stream from nurseries up and down the country, including one here at Lancaster. We have the same thing going for the bumblebees. And with the new updated version of BEEBOX, we're looking forward to having the ability to have even higher quality video broadcasts this year. And then lastly, what we can talk about is the possibilities with BEEBOX are enormous. The ability to properly study these bumblebees and do things with bumblebees we never thought possible before really just sort of blows my mind. And we've got loads of options. We can do things like conserving bumblebees in urban settings. Jenny and I are supervising a master's student who has just finished production of their first run of building mounted nest boxes, based very much like the same thing you see for swallow nest boxes and bat boxes, just ones you can attach to the side of your house, have a nest box there for things like a tree bumblebee to come and nest in. We've got the ability to do smart monitoring. So with the addition of this Raspberry Pi microcomputer, we can monitor all kinds of environmental, behavioral, chemical, nutritional factors going on inside the hive so that farmers need no longer rely on a cardboard box full of bees to keep their crop pollinated. That will last maybe 2 weeks. They can now have a smart monitored bee box, which will enable them to monitor how the bees are doing, if they need to put out more food for the bees, if they need to take that bee box out for recovery outside of the greenhouse. One of the really, really neat things we can do with this is because we can produce several thousand of them at a relatively cheap price, we'll be able to deploy them in the field in a very controlled grid-wise fashion to finally answer that question of why are bees choosing these places in particular? And what is it about these places that makes for good sites for nesting? Because those are questions we have never been able to answer before. So this nest box, again, it's very much like one you find mounted on the side of buildings for birds and bats. One of the things that continuously comes up and is continuously told to me whenever I talk about bee boxes in people's gardens is this idea that, oh, I really just don't like it when bees nest in my eaves next to my bedroom window. I find it worry I'm going to get stung by them. What's better for that than saying, that's fine, that probably won't happen again, because now we have the ability to give them an actual space that's for them, that's ideally not next to your window. And finally, the last thing I'm truly excited to talk about is the really out there stuff we can do with BEEBOX. So there exists 3 species of bumblebee that live within the Arctic Circle in Europe. And because they are quite remote, we don't really know very much about them. We don't know what they feed on. We don't know where they nest. We don't really know how many there are. We don't know about the distribution. We have very limited idea of the distribution based on historical museum records. These museum records extend from 1908, where there are about 500 records total of all Arctic bumblebees, and then nothing for the last century until a person in Russia, Grigory Potapov, did a study in 2014. Now, ideally, we can bring BEEBOX to the Arctic. We can get Arctic researchers to tell us how to improve it for Arctic deployment, and in so doing, use it to study these rare, unusual species of bumblebee that live in the Arctic tundra. Now, finally, for those of you in person, I have an extra special treat for you. At the back of the room, we have got a box full of bees for you to meet. For those of you watching online, please check my Twitter feed and the university's Twitter feed and the YouTube link that is in this presentation on the previous slides, because I will be switching the bees over to their YouTube live stream as of last year, same as last year, from tomorrow morning onwards. So you can all tune in and enjoy the secret lives of bumblebees once again. And thank you, everyone.